Hello everyone. So we are discussing our second unit, that is units and measurement. And units and measurement we are about to finish, okay? Because here we have studied about how to calculate error, okay? How to calculate that one, the absolute error, how to calculate mean absolute error, how to calculate random error, how to calculate percentage error, error as a sum or a difference, error as a multiplication or division, error as a power of means in the form of exponent. These things we have done. Okay, so we will solve some numerical from the example and some from exercise also, and only one small topic is left, that is rounding off. Okay, so the topic that we will discuss is rounding off the uncertain digits. So there are some rules. So and I already told you guys to make some notes, okay, from the significant figures. I have already given you the notes from this combination of error. मैंने बोला था कि जो rules text book में है in bold letters, these rules you try to write, because definitely you will get question based on this in your exam. So topic here is, chapter is units and measurements. Units and measurements, okay, and the topic here is for to the rounding off. This is also directly given in your textbook, that is a rounding of uncertain digits. Rounding of uncertain digits. So I will tell you the rule with the help of some example and then this topic will also over. So in rounding of uncertain digit, so the first rule is that the preceding digit is raised by 1 if the insignificant digit to be dropped is more than 5. Okay, so what is the first rule? First rule is rule number 1. The preceding digit, preceding matlab, I will tell you with the help of an example. The preceding digit is raised by what value? The preceding digit is raised by 1 if the insignificant digit to be dropped, if the insignificant digit to be dropped is less than, you are raising the value is greater than 5. Okay, the preceding digit is raised by 1 if the insignificant digit to be dropped is greater than 5. For example, suppose 74.967. Then if I round it off up to 4 significant figures, then it will be, dekho, the last digit is greater than 5 na, so this one is known as preceding digit, 6. Okay, this is known as your preceding digit. So you have to raise this digit by 1, that is answer will be 74.97. Okay, so this is about the first rule. Number 2 is exactly the opposite of this, that is the preceding digit is left unchanged. The preceding digit is left unchanged if the insignificant digit to be dropped, if the insignificant digit to be dropped is less than 5, okay, is less than 5. For example, suppose here only this is suppose 74.964. So the last digit that we want to drop is less than 5 na. So the preceding digit will left unchanged, okay. So ये है rounding off का second method. Number 3 is if the preceding digit is even, if the preceding digit is an even number, if the preceding digit is an even number, comma, the insignificant digit is simply dropped without any change. Without any change, okay. If the preceding digit is even, oh sorry, इसमें थोड़ा सा मिस्टेक हो गया. If the preceding digit is even and the insignificant digit to be dropped is 5 and the insignificant digit to be dropped is 5, comma, if the preceding digit is even and the insignificant digit to be dropped is 5, then it is simply dropped. Matlab there will be no change in the number. For example, suppose the digit is like this, 74.965. So 5 is not less than 5, not greater than 5. So you cannot use these two rule. But the preceding digit, look at this one. This is even, na? So it will be 74.96. You simply drop 5. Okay. Acha. Number 4th rule, that is, if the preceding digit is odd, and the digit and the insignificant digit to be dropped is 5, comma, then the preceding digit is raised by 1. For example, suppose the digit is like this, 74.935. What is the last digit that we want to drop? 5. But what is the preceding digit? It is 3, na? So if we round it off, it will be 74.94. So this is the rule. These are the 4 rules in case of this one, rounding off uncertain digits. Okay, this is about rounding of uncertain digits. Now we will go for solving some numericals. So basically here the numericals will be either from dimensional analysis or from error. Okay, so we will now solve some problem from error, that is from random error or percentage error. So you purchase some reference book. In reference book you can purchase modern ABC of physics, or New Millennium Physics. These two books, they are very helpful, so you can purchase these two books. One more book is there, that is New Simplified Physics or Newly Simplified Physics, like this by S.L. Arora. That also you can purchase, but the good book, that is your that one, Modern ABC of Physics, or you can purchase New Millennium Physics. Okay, acha. So first we will solve some numerical from the example itself. So look at the example number 2.12. 2.12 पे देखो क्या दिया हुआ है. The period of oscillation of a simple pendulum. So you already know that what is the time period of a simple pendulum. The time period of a, this is example 2.12. Okay, what is the time period of a simple pendulum? This is given as t equal to twice pi root over L divided by Z. You know what is L? देखो, if this is the pendulum here, this one, and suppose the pendulum, it is moving like this. So what is the L? L is nothing but this is known as bob. This is known as bob, B-O-B, bob of the pendulum. This is the string and this is L. You can consider as small l or capital L also. Here they have given it as capital L, na? So this length of the string, this is known as capital L. So the pendulum is executing to and fro motion. Okay, so pendulum के बारे में हम लोग को बहुत डिस्कस करना पड़ेगा in this HS first year. अब देखो, measured value of L is 20 centimeter. So what is the measured value of L? The measured value of L is 20 centimeter given. Known to 1 millimeter accuracy. तो उसका accuracy कितना है? Accuracy is 1 millimeter. अगर accuracy and precision, तो when we discussed accuracy and precision, there I told accuracy is 1 mm. What do you mean by this? मतलब जो maximum error है, that is your equal to 1 mm. Okay, so here delta L, accuracy, that is delta L is given as is equal to 1 mm. So in terms of centimeter, it will be 0.1 centimeter. Okay, accuracy, suppose accuracy is 1 millimeter, na? So you can write that L will be, in some case it will be say 20.1 or 20.2. This is what? This is 0.1 centimeter, na? So but it cannot be 20.24 centimeter like this, because then accuracy will be what? Accuracy will be more. It will be, this is more precise value, na? 20.1 or 20.14. Which one is more accurate? Obviously accuracy is different, and which one is more precise? This one is more precise because it can read up to 0.01 millimeter, but it can 0.01 centimeter, but it can read about up to 0.1 centimeter only. Okay, तो इसका जो स्केल है, it can read 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, उसका बाद फिर से 1 आ जाएगा. ठीक है, but this is more precise, but here accuracy is given as 1 millimeter. So error जो है, error can take place up to 1 mm only. So what is the error? Error is given as 1 mm, मतलब 0.1 centimeter. Okay, this problem is very very important, and the time for 100 oscillations is found to be, so what is the time taken? Time for 100 oscillation is found to be 90 seconds. So this is the time taken. This is the time taken, and time taken is given as 90 seconds using a wristwatch of 1 second resolution. So what is 1 second resolution? 1 second resolution means it can read up to minimum value of 1 second. तो मैंने बोला था list count में, if resolution is 1 second, then what is the list count? Then list count will be 1 second. Then what is the list count error? सबसे minimum error कितना हो सकता है? That is your equal to 1 second. So from here, this is resolution. इसको थोड़ा याद भी रख सकते हो तुम लोग कि जो accuracy दिया होगा that is the error, जो resolution दिया होगा that is also the error, maximum error. So this is given as 1 second. अच्छा, now you have to calculate in this problem what is the accuracy in the determination of Z. Accuracy in determination of Z means what? We have to calculate percentage error. मतलब कितना accurate है? 1%, 2%, 4%, कितना accurate है? That is we have to calculate. और कितना error है वहाँ पे? अब देखो accuracy in determination of Z ना, this formula you square both sides. T square equal to twice pi into L divided by Z. We want to calculate the error in Z, so it will be twice pi into L by T square. So what is the error in Z? That is del Z by Z is equal to, देखो twice pi is constant, so no error here, so it will be delta L by L plus 2 times of delta T divided by T. So what is delta L? Delta L is 0.1 centimeter. So this is 0.1, this is 20. So centimeter, they will be cancelled out, plus 2. What is the error? 1 second divided by 90. So it will be 0.1 by 20. So 0.1 divided by 20, just a moment. 0.005, 0.005, and another one is 2 divided by 90, so that is 0.02. So it will be 0.07. Okay, is it 0. 1 by 20, 0.1 divided by 20, 0.1 by 20. Oh, this is 0005. So this is 005. So it will be 0.027. Okay, so last digit is what? Last digit is 7. So it is greater than 5, so you round it off, it will be what? It will be 0.03. So what will be the percentage error? So the percentage error will be 3%. 0.03 into 100%, na? So it will be 3%. Matlab, what is the accuracy? Accuracy is 97%. Okay? You cannot get a device which is 100% accurate. So, but this time, whatever the device we are using, what is the accuracy of that device? Or error? Error is 3%. Matlab, it is what is the that one? Accuracy in the measurement. So accuracy will be 97%. So the device we can recommend as a good device. Okay, since the accuracy is high. So this example is very, very important for your exam. So next one, we will now go to exercise. Question number 2.10 is your homework. So formulas are given directly, so you apply it. Otherwise, I will give it to you, the solution. So, अच्छा, exercise में देखो question number 2.3. अच्छा, you do it question number 2.1. Question number 2.1 you can solve it. These things we will not do in our class. Fill in the blanks by suitable conversion of unit 1 kg meter square per second square into gram square plus ग्राम सेंटीमीटर स्क्वायर पर सेकेंड स्क्वायर. देखो इसको हम लोग कैसे करेंगे. 2.2 का क्वेश्चन नंबर 1 kg पर मीटर पर सेकेंड स्क्वायर को ग्राम पर सेंटीमीटर स्क्वायर पर सेकेंड स्क्वायर पे लेके जाना है. तो हाउ वी विल कन्वर्ट. तो सुइटेबल कन्वर्शन यूनिट भी बोला है वहाँ पे ना. सो हाउ वी विल सॉल्व इट. देखो अभी यहाँ पे so what is this 1 kg meter square per second square. So this is the given system of unit. यहाँ पे n का वैल्यू कितना है, फॉर्मूला पे डालेंगे डायरेक्ट 1. ठीक है. what is m1? this is given as in kg. what is l1? this is given in meter. what is t1? this is given in second. this is the one system of unit. What is the another system of unit? That is N2. So whatever the value of N2 that we do not know, whatever the mass in the second, that is we know, gram, 1 gram. What is length? centimeter, and what is time? Time is in given in second. So if we can we have to calculate the value of n2. So I already gave you a formula, that is n2 is equal to n1 m1 by m2 to the power a. Acha, what is ABC here? Kg, meter square per second square. So what is a? A is 1, B is 2, and C is -2. So this is L1 by L2 to the power B, T1 by T2 to the power C. So N1 is given as 1, M1 is equal to 1 kg divided by 1 gram, A is 1, L1 is equal to 1 meter by 1 centimeter to the power 2. This is 1 second by 1 second to the power -2. तो ये सेकेंड का काम तो ख़त्म हो गया, इस पर कुछ है नहीं. अच्छा, नेक्स्ट 1. व्हाट इज़ 1 kg? दिस इज 1000 ग्राम बाय 1 ग्राम. ग्राम ग्राम कैंसिल, 1 टू द पावर 1, इसका कोई काम नहीं है यहाँ पे. 1 मीटर इज 100 सेंटीमीटर by 1 centimeter to the power 2. So from here we can write that this is 10 to the power 3, this is 10 square, so to the power square, so this is 10 to the power 4, so this is 10 to the power 7. So fill in the blanks पे वो value कितना आएगा? It will be 10 to the power 7. So remaining 3 you try to do it by yourself. Second one you already know that 1 meter is equal to कितना light year, already I think given something 1.496 या कितना था, ठीक है. थर्ड वन जो है बाय यूजिंग दिस फॉर्मूला ट्राई टू सॉल्व इट, एंड जो फोर्थ वन है दैट इज ऑल्सो बाय यूजिंग द सेम मेथड ट्राई टू सॉल्व इट. सेकेंड वन यू कैन डू इट डायरेक्टली. अच्छा, क्वेश्चन नंबर 2.3 पे देखो. ए कैलोरी इज ए यूनिट ऑफ हीट, ओके, एंड इट इक्वल्स टू 4.2 जूल. सो फ्रॉम टुडे ऑनवर्ड्स रिमेंबर वन थिंग, that is 2.3, that is 1 calorie is equal to, actually it is 4.186 joule, actual value, but the approximation after round off is 4.2 joule. So remember that 1 calorie for numerical purpose we will consider it to 4.2 joule. This is given. अच्छा, 1 joule equal to कितना? That is 1 kg meter square per second square. So 1 joule is equal to 1 kg meter square per second square. Done. Suppose we employ a system of unit in which system of unit of mass equals to alpha kg, unit of length is beta meter, and the new unit of time is gamma second. तो we have to show it. जो राइट साइड में है that is we have to show. देखो, जो पुराना सिस्टम ऑफ यूनिट है, here A1, B2 and C equal to -2. This is given. So we have to show that calorie na. So in one system N1 is equal to 1 calorie equal to 4.2 joule. So N1 is equal to, we will write here 4.2. Okay, what is the mass? M1 equal to 1 kg. What is L1? 1 meter. What is T1? 1 second. This is one system of unit, and we are converting it to another system of unit where we do not know about N2, but M2 is equal to given as alpha kg. M2 is given as alpha kg, and we do not know what is alpha, and length is beta meter. So L2 is alpha meter, this is alpha kg and beta meter, and T2 is something gamma second. So we have to find out the value of N2, and it must be 4.2. So that calorie has a magnitude of 4.2 alpha inverse beta to the power -2 gamma to the power 2. देखते हैं उसका magnitude, मतलब N2 का value कितना आता है. That must be equal to this one given in your textbook. So the same formula we will use here. Same formula we will use here. So I have erased this portion, then this portion also. So we are going to use the same formula for conversion of unit. Okay. So from right you come to this portion. So N1, this is given as 4.2. M1 is given as then 1 kg. This is your equal to alpha kg to the power 1. kg mar gaya. L1 is equal to 1 meter. Next one is equal to beta meter. So meter khatam. So T1 is equal to 1 second. T2 is equal to gamma second to the power minus 2. Second khatam. So N2, that is the magnitude, will be 4.2. अगर अल्फा ऊपर गया तो ये हो जाएगा अल्फा इनवर्स, बीटा ऊपर गया तो ये हो जाएगा बीटा टू द पावर माइनस 2. गामा ऑलरेडी माइनस इज देयर, सो इट विल बी गामा टू द पावर प्लस 2. yes, hence it is proved. Okay, alpha inverse beta to the power minus 2, gamma to the power plus 2. Done. And so 2.4 is not required. 2.5 is homework, तुम लोग कर लेना ये. 2.6 भी कर सकते हो. 2.6, okay, you can do it. Then 2.10, how many significant figures are there? The rules I have given already. Use these one. The length, breadth and thickness of these one. So what is the area and volume? So use the rule of significant figure. Same. So 2.13 is the, so 2.11 is homework. 2.12 you can do it in your home, simple. 2.13 I will do it now. 2.14 is homework. Remainings are not so much important, but you can do it. But whatever I have mentioned as a homework, so please solve it. So 2.13 पे क्या है देखो. A physical quantity P is related to, अच्छा formula पे ये है. What is the percentage error in the quantity P? If the value of P is calculated above the result 7, what should you round off to the result? ठीक है, स्टेप बाय स्टेप करते हैं इसको हम लोग. So it's 2.13. So some physical quantity is there and it is represented by capital P. Okay. P is a cube b square. P is 2.13. P is a cube b square divided by root over c into d. So percentage error calculate करने के लिए first we have to calculate relative error. 3 times of delta a by a, 2 times of delta b by b. ये देखो ये रूट सी है ना, तो उसका पावर क्या होगा, हाफ. सो इट विल बी हाफ डेल्टा c by c प्लस d का तो कोई पावर है नहीं, तो इट विल बी डेल्टा d by d. So percentage errors are given directly. So delta p by p will be 3 into, what is the percentage error in A? It is 1%, 1342 na. So this is 1%, this is 3%, 1, 3, 4 and 2. So this is 4% and this is 1, और यहाँ पे तो 1 है, this is 2%, okay. So this is cancel, so it will be 2, so 3 plus 6 plus 2 plus 2%, 3 plus 9, 9 plus 4, 13. So here you mention percentage error, huh? Delta p by p into 100%. So the percentage error will be 13%. So whatever homeworks I have given, you solve it in your home. I will check the homework copy when our classes will reopen here. So with this I will finish this chapter. So the important part from this chapter is the rules for significant figures, then numericals from dimensional analysis, and the numericals from error. Definitely you will get question. Done.